Welcome to lecture 6.2 Trigonometric Functions, the unit circle approach. So we're going to be looking at our trigonometric functions using specifically the unit circle. Our objectives for this section are to find the exact values of trigonometric functions using a point on the unit circle. Find the exact values of the trigonometric functions of quadrantal angles. Find the exact values of trigonometric functions of pi over 4, where we have 45 degrees. Find the exact values of the trig functions of pi over 6, where we have 30 degrees, and pi over 3, where we have 60 degrees. Find the exact values of trig functions for integer multiples of all three of these: pi over 4, 45 degrees, pi over 6, 30 degrees, and pi over 3, 60 degrees. Use a calculator to approximate these values of trig functions, and use a circle of radius r to evaluate the trig functions. So let's jump right in. We've got a lot to cover today. Again, we're looking at the unit circle approach. So if you haven't already, I highly suggest you memorize the big three at minimum of our unit circle. Because once you memorize the big three, pi over 4, pi over 3, and pi over 6, 30, 45, 60, then just by using our knowledge of what happens when we go over the y-axis, our knowledge of what happens when we go over the x-axis, you'll be able to identify all of these big degrees. So what I'm talking about is, if I know that pi over 4 has root 2 over 2, root 2 over 2, as its x and y coordinates, or its sine and cosines, right? Then by flipping over the y-axis, that means that my x's are now a negative version of what they used to be. And if I flip over the x-axis, my y values are a negative version of what they used to be. And then if we go totally across both x and y, then both x and y are now negative versions of what they used to be. So that's what I'm saying is, once you get the memorized pi over 3, pi over 4, and pi over 6, then just by knowing what quadrant you're in, you're able to figure out the rest. So, I mean, by all means, if you memorize them all the way across the circle, then awesome. But what I would do is focus on those three and the understanding of what happens as I move around the circle. And it will make your life a lot easier in this pre-calculus class. Okay, now let's say we're given a specific point on the circle and we want to know what are the exact values of these trig functions if my point has coordinates negative square root 11 over 6 and 5 over 6, corresponding to our unit circle. So this is talking about if I place a point on my circle and my x is negative pi over 6, so it's somewhere on this side because my x is negative, my y is positive, then what would my trig functions be in relation to the unit circle? So let's start with sine. What do we know about sine? Well, it would be the y value. So in this case, my y value is 5 over 6. And that's it. Cosine, moving on. What do I know about cosine? Well, it's my x value. And in this case, my x is negative root 11 over 6. So far, so good. Tangent. What do I know about tangent? Well, I know that tangent is sine over cosine, which represents y over x. And so I would take my y and put it over my x. And now I have to do some algebra to make sure I don't have a fraction in a fraction and a square root on the bottom. So 5 over 6 divided by negative 11 over 6. I'm going to use some division properties where I keep the first, I turn it to multiplication. I'm not going to use an x here because we're already using an x as a variable. And then I flip the second. So that's going to leave me with negative 5 over root 11, which we're going to want to get our root out of the bottom. So if I multiply by root 11 over root 11, this doesn't change my value because square root 11 divided by square root 11 is 1. So it's like I'm multiplying it by the most complex one I've ever seen, right? So square root 11 times square root 11 would leave us with an 11 on the bottom, and we have negative 5 root 11 on the top. And that we will stop with since our square root is no longer in the denominator. Next up, let's do cosecant. What do we know about cosecant? It's 1 over sine, which is representative of y. 1 over my y of 5 over 6 would just be 6 over 5. Next we have secant. And what do we know about secant? Well, we know that secant is 1 over cosine, which is representative of 1 over x. And 1 over x is 1 over my negative root 11 over 6, which is negative 6 over root 11. And again, we want to get that root out of the bottom. So I'm going to do the same thing. I'm going to multiply by root 11 over root 11. And that will leave me with negative 6 root 11 over 11. Lastly, cotangent. What do I know about cotangent? It's 1 over tangent. And that would be cosine over sine this time. My cosine is representative of x. My sine is representative of y. So this leaves me with negative root 11 over 6 over 5 over 6. I'm going to use those division of fraction properties again. Negative root 11 over 6. Change it to multiplication and flip the second. So this is negative root 11 over 5. And that is all 6. So we have our sine is 5 over 6. Cosine is negative root 11 over 6. Tangent is negative 5 root 11 over 11. Cosecant is 6 over 5. Secant is negative 6 root 11 over 11. And cotangent is negative root 11 over 5. We have discovered all 6 at that point. All right, moving right along. We want to find the exact value of tangent of 8 pi. So if we take a look back at our unit circle, what I'm going to do is I'm going to bring the unit circle with us to this specific problem. There we go. We're looking at 8 pi. That's where we want to be. So here we see we have a pi. And if we keep going, so that's if we go around our unit circle, we'll end with a pi. If we keep going, we'll have 2 pi. If we keep going, we'll have 3 pi. If we keep going, we have 4 pi. And we keep going, we have 5 pi. And do we see what's happening here? If we keep going, we'll have 6 pi. And we have even pi's and odd pi's. So what I'm going to do is, instead of cluttering up our unit circle here, we have even pi's over here and odd pi's over here. So I'm looking at 8 pi, I'm going to end up over here. Okay, that's if I kept going and going and going and going, I would end up at 8 pi right here. So we want tangent of 8 pi. Tangent is our sine over cosine. And that represents our y over our x. And in this case, we have 0 over 1, which leaves us with 0. So tangent of 8 pi will give us 0. Okay. Let's take a look at some more. So we are looking at pi over 4, pi over 6, and pi over 3 now. We want to know the exact value of cotangent 13 pi over 4. So let's start with what we know about cotangent. Cotangent is 1 over tangent, and that would leave us with the opposite of tangent. Tangent's usually sine over cosine, so now we're going to have cosine over sine. Now if I'm looking at my unit circle, and I want to know, where is 13 pi over 4? So what I would do is I would focus on where the pi over 4s are. And they happen right in the middle spaces. So if I wanted to figure it out and I was having difficulty picturing where is 13 pi over 4, I would just count passing 13 of them. And that would end up leaving me, I would go around and around and around and around, and I would end up here, actually. So that is the one we want to focus on. That gives us 13 pi over 4. This is our angle that we're looking at. Now, like I said before, memorizing our values at these main angles is super duper helpful, because now I know that my values here, my coordinates, are negative root 2 over 2 and negative root 2 over 2. Because that's one of the big 45s. Now what do we do with this? Well, we plug it in. We know that cosine and sine are representative of our x and our y, so we are going to put in negative root 2 over 2 over negative root 2 over 2. And then we'll use what we know about fraction division, negative root 2 over 2 times 2 over root 2. And this all multiplies out to 1. Next up, we'll look at cosecant of 765 degrees. What do we know about cosecant? We know that it's the same as 1 over sine. And if we are looking at it on the unit circle, where is 765 degrees? Well, think about how many degrees does it take to get around the circle completely one time? That's right, 360 degrees. So if we wanted to find 765 degrees, we would be going around, and we would keep going around, and we would actually land right here. 765 degrees, which is our big 45. So what do we know? Then we know that those coordinates are going to give us root 2 over 2 and root 2 over 2. I'm telling you, memorize that unit circle. At minimum, the big three. 30 degrees, 45 degrees, and 60 degrees, because you should already know 0 and 90. So these big three are going to help out a ton. So what do we know? Well, we can find our sine of t, so we will have 1 over root 2 over 2. And that leaves us with 2 over root 2. We don't want our radical in the bottom, so we'll just multiply it by root 2 over root 2. That way we don't change the value of it. So we have 2 root 2 over 2, and those 2's will cancel out, which will leave us with root 2. Cosecant of 765 degrees. Let's do sine of 7 pi over 6. Sine of 7 pi over 6. Well, what do we know about sine? We know that sine t is our y value. So where is 7 pi over 6 on our unit circle? If you want to pause and find it, that way you are giving it a try, that'd be awesome. 7 pi over 6 is right here. And our coordinates at 7 pi over 6, negative root 3 over 2, and negative 1/2, one of our big three. And our y value, simply put, is negative 1/2. Sine was a nice friendly one, isn't it? Okay, let's do cosine of 330 degrees. So cosine is going to be another friendly one because we know that cosine is our x value. So let's find 330 degrees. Well, I started by referencing if I go all the way around the circle completely, I would end up with 360 degrees. So I'm just going to be 30 degrees short of that at 330 degrees. So I go all the way around and end right there. That's one of our big three. So I know my coordinates, root 3 over 2 and -1/2. And since I'm looking for cosine, which is my x, then I know my answer, root 3 over 2. Referencing back to that unit circle is so beneficial. It's extremely, extremely helpful. All right, tangent of 300 degrees. What do we know about tangent? Well, we know that tangent is the same as sine over cosine. So let's get a reference on our unit circle. Where would 300 degrees be? Well, if we went all the way around the circle completely, we'd be at 360. So that means we're 60 degrees short at 300. So we ended right there. And if we know our big 3, which we should by now, we know that our coordinates here are 1/2 and negative root 3 over 2. If we put sine over cosine, then we will be putting negative root 3 over 2 over 1/2. And I'm going to use my fraction division knowledge. Negative root 3 over 2 times 2 over 1. This leaves us with negative root 3. And our last one, secant of 4 pi over 3. What do we know of secant? We know that secant is 1 over cosine. So if we find (4 pi over 3 on our unit circle, you should be about here. So we went around the circle and ended right there. And our coordinates here are negative 1/2 and negative root 3 over 2. Secant is 1 over cosine, so that would be 1 over negative 1/2, which is negative 2. And we have done it. All of our trig functions at different angles around the unit circle, whether it's in degrees or radians. We should be able to find these angles and then use our properties of trig functions to determine what these values are. Okay, now I want to get some practice putting these things into the calculator. So grab your calculator, and we're going to start with cotangent of 3.2. So first, we need to put cotangent in, and there is not a cotangent button. So what we're going to do is use what we know about our properties. What do we know about cotangent? Cotangent is 1 over tangent. So that's what we want to put in. 1 over, and we know tangent of 3.2. And as we can see, that's approximately 17.1. Now, yes, you may have seen the Desmos calculator does give me a cotangent button, but if you're using a TI-84, you won't have a cotangent button. So you're going to want to do it this way. All right, next we have cosecant of 515 degrees. So the first thing that I want to do is set to degrees. So on your calculator, find the mode button. On mine, my mode is on the very top, right next to the second button. So if I click the mode button and I go down by 2, it will give me the option to have it in radians or degrees. So I'm going to move it over to radians, press enter, and then clear out of there. That's setting it to degrees. Now I can plug this into my calculator. So, cosecant, what is cosecant? Cosecant is 1 over sine. So I can plug that in, 1 over my sine of 515 degrees. Let's see here. It doesn't look like this has degrees. So we just won't use that one. Let's see, maybe it's on here. No. Anyway, if you plug this into your calculator and you have it set to degree mode, then this should be approximately 2.366. And as you can see, if you don't have it set to degree mode, then you will get a totally different answer. Oops, 1 over the sine of 515. So it's very important to have it in the right mode, whether you're measuring in degrees or radians. For the next one, it's in radians. So the first thing we need to do is set to radians. And we go to the same place. Go press mode, put your cursor on radians, press enter, and then clear out of there. And now that it's set to radian mode, we're just looking for cosine, so we can plug that right in. Cosine of 5 pi over 7. If you put that in your calculator, cosine 5 pi over 7, that should give us approximately negative 0.623. Desmos is working in radians. I'm gonna have to look it up how to turn it into degrees. There it is, look, there it is. I found it. Okay, so I want to go back and do the other one. 1 over the sine of 515. And if I have it in degrees, you can see that the sine of 1 over the sine of 515 degrees is that 2.366. Awesome. Okay, and you also got to learn how to change your Desmos into degrees and radians. All right. Alrighty. Next up, we are going to take a look at a specific point on our circle and find all of our trig functions, our values for our trig functions. So here's our point. Our point is -10, -2. That's the terminal side of our angle theta, and we want to find the exact values of our trig functions. So on our circle, this angle, -10, -2, would be somewhere about here. So first, let's write out our trig functions. We're looking for sine theta, which is representative if you've read the chapter, which I'm expecting you already have, y over r, cosine x over r, tangent y over x, and then we also have cosecant r over y, secant r over x, and cotangent of x over y. The first thing, because we have x and we have y, what we don't have is our r. We don't have our radius. So that is what we need. In order to find our radius, we are looking at what is this distance, right? And if we remember about triangles, we can find a squared plus b squared equals c squared. So our r, our radius, is -10 squared plus -2 squared, and we're taking the square root because it's not r squared. We want just r. So this would give us 100 plus 4, which gives us the square root of 104, and we can rewrite that as 2 root 26. So we have x, we have y, and we have r. So let's start finding out what are these values. So our sine of theta is y over r. This is -2 over 2 root 26, which reduces to -1 over root 26. And we don't want that radical in the bottom, so we're going to do radical 26 over radical 26, which leaves us with negative root 26 over 26. Okay, cosine is x over r, so this is -10 over 2 root 26, which reduces to -5 over root 26. And we multiply by root 26 over root 26, which gives us -5 root 26 over 26. Next up, we have tangent y over x, -2 over 10, -10, I'm sorry, which is 1 over 5. Cosecant theta is r over y, which is 2 root 26 over -2, which leaves us with negative root 26. Secant theta is r over x, which is 2 root 26 over -10, we can simplify that to negative root 26 over 5. And lastly, we have cotangent, which is x over y, which is negative 10 over negative 2, which leaves us with 5. And that's all I have for today. This summarizes section 6.2. Just as a reminder, as we're going through these lectures, I do expect that you have read the chapter before you've watched this lecture. That way you aren't lost or behind as we go through the examples. You should be reading the section and completed your guided notes before you watch them. So if you must, please go back and do that and then watch this again. That way it makes sense.